What's up, guys?
Just the two of us.
Just the two of us.
I'm fucking faded.
Faded, dude. You're too young to be faded.
You never know.
How's Vape Simulator on VR chat?
I don't even play that anymore, bro.
Dude, what?
I play COD. I've been playing COD. I got right back into 6H2. I just got the battle pass for it.
Oh wow.
Or like the pass.
I don't know. I'm kind of fucking. I'm done with COD, dude. Like I played some the other day, and I was just like, this game is trash. I can't play
Rainbow
it.
Six Siege.
Yeah, maybe we'll get in Siege. Maybe. You guys keep telling me to play Rainbow
You
Six
have
Siege.
it?
I don't, but y'all keep telling me to go get it. What's up, Taco? What's up, Taco?
Rock and roll McDonald. Oh my god, that voice crack. Oh my. Oh, that's embarrassing.
Ooh, wow.
That's me.
Taco Cat with the 1 minute delay. It's okay, Taco. I appreciate you remembering. But yeah, try to maybe ping the students like 20 minutes before, 30 minutes before. I have a French exam tomorrow, so I'm going to fail miserably. No, you're not. No, you're not, Teacup. No, you're not.
I have a Spanish test Friday. Can you help me?
¿Qué tienes ayudar con?
The fuck? I'm too fucked up for this shit.
¿Qué cosas necesitas para me ayudarte? Is that how I say it? I don't know.
Did you say? What do you need?
Obama, was it okay? Obama, was my Spanish okay there, dude? You tell me.
Hola. Mi amo. Redacted.
Hazy, don't ban me, please. My cousin got on my comp. What'd you do? What did you do?
Never trust anyone that says that their like brother or something got on the computer.
Yeah, I don't know. Like what'd you do?
Because they're probably lying. They spammed the N-word about 15 different times.
It's okay. He deleted it. Ugly happy. Oh no. Oh, it's okay. Yeah. Don't say the N-word, please, in my server, dude.
Did I call it?
Yeah.
Did I call it? Oh my gosh.
It's okay. The auto mod will like prevent him from saying that, but don't.
Yeah, but on the other hand, I have swearing perms.
Swerve. Hello, what's up, Jamarcus?
Oh wow.
You being bad to Nightbot Gold? Yeah, don't be bad to Nightbot. Be nice to Nightbot. Nightbot's our friend.
I'll abuse the Nightbot. I don't give a fuck.
What do you mean 1 minute delay? Oh, sorry, like 1 minute. You announced to the students 1 minute before the stream started, which is okay. You at least announced to the students. I'm happy you did that. I'm happy someone did. I'm on the research paper grind. Nice. All right, here. I know we got a lot of questions. I saw that, Hazy. You don't have to repost a screenshot of you saying stuff. It's okay, Hazy. Just don't repost it. Okay.
Hello. Hey, it's Jamarcus.
Let's do some questions. Yeah, what's up, Jamarcus? All right. Welcome, everyone, to Office Hours. My name is Dr. Gold, Sexual Education, stream that helps you with math, homework, science, homework, all types of fun stuff. What's going on? It is Wednesday. Life is great. Equity says I have to go by 8:25 EST. Isn't that in like 20 minutes, bro?
Damn.
That's pretty
Damn.
That's pretty soon. Jamarcus, I want to come to more streams, but I genuinely don't have the time. Why? What else are you doing? Is this the Russian math thing you're doing? Yeah, I can do
Russian math?
Russian math.
Yo, if I pull black ice, you gave me a bond coin, alright?
Mm-hmm. Just finished asking Ian Stuckey a question. Is he streaming right now? Is he live? It's like, let me see live. Yeah, Dawn, Ian. Yeah, exactly. You know, you guys, don't feel like you're cheating on me. It's cool. Like please go follow the other math streamers. If I'm not online and you need help with math homework, yeah, go help those guys. Yeah. Here.
Dr. Did you say go follow the other master?
Go follow the other math guys is what I said. Math guys. So
I thought you said don't go follow the other masters.
no, there's a whole list of
Bro.
other people that stream math help. You should be following all of them. So like if I'm
Yeah,
not
I
online to
did.
help you guys and you need help with math, a lot of these people are running streams where they do free homework help.
I was kidding.
It's okay, you know now, Bob. It's all right. You know, the best time to plant a tree was 40 years ago. Second best time is today. It's okay.
Real.
Yeah, real. So yeah,
I
don't
can
worry.
agree. Yes.
Would have been
Bro,
it'll be useful. It'll be useful in the
bro.
future. All right, here. Let's do Equity's question. He's got to bounce in like 20 minutes. Okay. Two ships
I'm gonna
S and T are 120 kilometers apart when they pick up a distress call from a yacht. Ship T estimates the yacht is 70 kilometers away and that the angle between the line from T to S and the line from S to the yacht is 28 degrees. What are two possible distances to the nearest 10th? Okay, cool. This is a law of signs case with the ambiguous case. It's actually pretty cool. Gold, do we get coins for asking from other streams? Currently, no. I do allow you to get MT coins if you haven't asked a question during the week for MT coins. You can still get credit. I said you could get credit for MT coins asking from other streamers. I'm not sure. The problem with me doing bond coins and whatnot is that starts to get a little bit out of hand. And yeah, I may. I've talked with the other streamers about this, but I'm not sure exactly they want to like keep track of stuff because then they would have to like tell me that you asked a question. Yeah, exactly. I could put a limit. Maybe we'll see. I mean, the other idea is the way that we had it with the MT coins, which is like just show me like just clip it. But the problem is that like some of these mass streamers don't have clips enabled, so you can't do that. It's more of a resource. So again, you can get coins right now on my stream. You can get channel points, which you redeem into coins. Cool. Yes. The other streamers are there to help you when you legitimately need the help, and the motivation shouldn't be that you're trying to like get bond coins, right? The motivation should be that you want to do well in your classes, and so that's a free resource for you. So use it. You know, I agree. People ask questions a lot of times here because they want to get gift cards. That's totally fine. That's the whole point of the server. But that does eventually transition to people like Bob, for instance. Like Bob is always asking questions because he legitimately wants to do well in his calculus class. And you know, the rewards is kind of like a bonus. So yeah, use the other streamers. My hope is that, you know, getting help here inspires you to get help elsewhere in your lives. And that can mean getting help from other math streamers. So yeah.
Hello.
What's up, Ethan?
You saw I'm off this?
I did, yeah. Congrats, dude. You got 100. See, I told you you're gonna be fine, dude. Yeah, you got 100, dude. Nice.
Yeah.
Good shit, dude.
Yeah, and you were right. I did get it before the end of the month, April.
Yeah, I knew it was gonna happen.
But I would want I would want some help on directing numbers a bit because I almost didn't get 100 because of that.
That's okay. Yeah, you can totally ask it. Let me do Equity's question. He's got to leave in like 10 minutes, so let me do his real quick, and then I'll talk with you guys all I want. Cool.
All right.
Awesome. All right, let's do Equities. Okay, so S and T. So I like drawing pictures. Are 120 kilometers apart. And Ship T estimates that the yacht is 70 kilometers away, and that the angle between T and S and okay, cool. So then there's a yacht. We got a yacht out here. Like, yacht's in trouble, right? Okay. And we say that this distance is 70, right? And then that this angle is 28 degrees, okay? And they want to know what are two possible distances from the yacht to ship S. Okay, that has to do with this. Okay. Yeah, this is the ambiguous case. I'm literally making a TikTok on it. I swear, I've been trying to put it out for the last couple days, but I keep getting sidetracked. It's like I got to tutor someone or like I got to stream or something just keeps happening. But I'm almost done with it. But this is exactly the law of signs. Jamarcus says, I actually have class for research thing in an hour, so I have to have dinner real right. Okay. Eat your dinner like while you watch the stream. That's totally cool too. Right? Anyways. I do post them on YouTube Shorts as well. Sometimes they do well, sometimes they don't. Yeah, I think TikTok's going away. Right? Didn't something get passed in Congress today? They're trying to ban TikTok. Like whatever. Probably should, honestly. TikTok's pretty fucking trash. But I like it because it enables me to reach students very easily. TikTok is very good for reaching middle school and high school kids, and so it's excellent for me getting my content to them. So that's why I like TikTok, but I do think TikTok probably has a net negative on society, so it's okay. Anyways, they want to know this here, equity. They want to know what this angle is, right? So here they're saying, what are two possible distances from shipped? Okay, so they really want this. Sorry, they really want this. Okay. All right. In order to get that, let's see. I almost have 3 sides. Oh, I have 3 sides in an angle. Are there? Wait, are there? Oh, maybe there are. Okay, here, let's look at this. Sorry, for okay, 1 sec. Wait, 2 ships, S&T are 120. Estimates that yacht is 70 kilometers away, and that the angle between the line T to S and the line from S to the yacht. Oh, this one's 28 degrees. Sorry, this is 28 degrees. This makes it a little bit more interesting. This is 28 degrees. Yeah, this is what they say. They say this is 28 degrees. Okay, cool. And then they want to know this. Okay, cool. All right, I'm going to call this thing angle. We're going to call these a couple of different angles. I'm going to call this like angle A. I'm going to call this angle B. All right. So this is weird because I have 2 sides and I have 2 angles that I'm looking for. That would be the law of sines, is what it would be. The problem is that the side I'm looking for, I also don't know the angle across. So I need to use these pairs first, and then once I know what this angle is, I can then figure out what this angle is, which means I can figure out this distance. So let's look how that works. So we're going to use this law of sines first. So I have the sine of 28 degrees all over 70 is equal to the sine, the law of sines, the sine of B over 120, right? So that gets me that the sine of B is equal to 120 over 70 sine of 28 degrees, okay? All right. So if we pull up our calculator, what does that get me? That gets me, so 120 over 70 times the sine of 28. Okay, cool. That gets me 0.469. Okay, so I have the sine of B. It's equal to 0.469, which then what I'm going to do is I'm going to take the arc sine of both sides, right, to get it by itself. Cool. All right, so arc sine of sine goes away. What do you mean I can't do that? Yeah, that's what, inverse sine is arc sine. It's the same thing. Because then I'm just going to do this. I'm going to do the inverse sine of that, right? Oh, I didn't multiply them by each other. No, you're right. I needed to do this. Sorry. It's this times this. Sorry, 0.804. No, you are, well, I did a math ouchies, or calculator ouchies. So, this is 0.804. Yeah, now I do the inverse sine of that. Yeah. Okay. And that gets me 53.5. Let's just say 53.6 degrees. So I get that B is equal to 53.6 degrees. Okay, now this is the tricky thing. Yes, ambiguous case. Literally, it is my TikTok. I'm almost done with it. I need to put it out because everyone's going through this right now, and I know it's like a hot topic I need to do. I honestly need to just like drop all the other things I do. I need to drop all my DJing. I need to drop all my other like activities because I feel like I have these TikToks that I get made, and it's just the editing, dude, takes hours. Like I can record the thing, but it's just like the editing just fucking sucks. And I've been meaning to get this one out for like a week or two. And if I'd gotten it out last week, I know this would have helped a lot of people this week because I know everyone's doing it right now. It's like what's popular, but what's popular is the same thing every year, right? Like this time of the year, everyone's doing law of sines. And then like, whatever time of the year, everyone's doing the quadratic equation. So yeah, if you want to make math content, it's great to just follow like what's being taught at that time of the year and try to get content out quickly, like that week. That's what I'm trying to do, but yeah, I'm finding a difficult time balancing all my other responsibilities, like paying rent. Anyways, okay, so B is equal to 53.6 degrees. the problem here is that when we do arcsine only gives me angles that are between here and here. It's only going to give me stuff from negative 90 degrees to positive 90 degrees. It does not get you stuff in quadrant 2. So it won't get you over 90 degrees. So what you have to do is you have to consider, okay, what would happen if I was, let's say, 180 minus 53.6 degrees. That's another possible solution for B. So if we do 180 minus that, I get 126.4 degrees. So this is also a valid solution for B. Do you know why that is, Equity? Do you know why there are 2 solutions? It's actually kind of cool. What is the calculator app thing I'm using? It's called Wabbit. Wabbit EMU. It's an emulator. Oh, see, no, this lesson is being taught tomorrow. See, that's why I need my TikTok to come out today. Okay, this is why. Okay, yeah, very good. Okay, so let's say this is so when we say, okay, when I say the sine of B is equal to 0.804, right? And I know that the sine of 53.6 degrees is equal. So let's say sine of B is 0.804. You know that the sine of something, right, is the opposite over the hypotenuse. So what's that what this question is asking is what angle, when I take the sine of it, do I get 0.804? And what I do when I do with the calculator is I say, oh, well, that is 53.6 degrees, okay? So 53.6 degrees, when I take the sine of that, gets me 0.804. Remember that the sine is the opposite of the hypotenuse. Hypotenuse is always 1 in the unit circle case. So this is where the opposite is 0.804, okay? Now, the issue is there's another place in this unit circle thing that also has the opposite being 0.804, and it's over here, okay? When you're over here and your reference angle is 53.6 degrees, let's see if we remember what like reference angles are, right, from doing like trig. This is also 0.804, okay? So the sine of this whole angle right here, this whole thing, the sine of this whole thing is also 0.804. So in that case, this is the 126.4. And you can kind of see this. You can see this on the calculator. So here, watch. So the sine of, right, 53.6 gets me around 0.804, right? And then the sine of 126.4, right, which is just 180 minus it, also gets me 0.804. That's why technically, this is why it's called the ambiguous case, because you have 2 different solutions. Both of these work. And it's only with the law of sines that this happens, because cosine is defined in both of these quadrants. So arc cosine is defined in quadrant 1 and quadrant 2, so you can have anything from 0 to 180. Okay, so these are 2 valid solutions. Now, something you can kind of like get rid of the ambiguous case is if one of these angles plus the other angle you have goes over 180 already. Let's say, for instance, for whatever reason, that this was like 60 degrees, okay, and that I still got the same things here, right? Right off the bat, I know that this answer does not work. Because if this was if this angle, sorry, was 126.4, 126.4 plus 60 is already over 180. So that does not work. Like, the 180 is the max you can have in a triangle. So that's a thing to check. So when you're doing law of sines and you're solving for the angle using arcsine, you should always check this and 180 minus it. And then knowing which one it is, you have to either look at the picture and determine, wait, should it be obtuse? Should it be acute? Or check if you're already going to go over the 180 limit by putting that angle in. That's how you figure out which one it is. This picture, right, isn't the one that I drew this picture. So it could actually be wrong. Because I think what you could have is you could have something like this. And this would also be legal. So that's why you get 2 different solutions. Yeah. It's pretty cool. Well, actually, so this is the acute solution. This is probably when this is 53.6. And then another solution that would work would be, I don't know, something. Oh, it's not like this, Jeff. What is it? It's like, I forget how it works. It's like, I don't know. Something where something moves around and it's somehow obtuse. Is it this? How does this work again? I'm trying to remember how this works. Oh, okay. Yeah. I don't. You can have it be obtuse. There was actually a really good thing I had on this. Where was this? It was this ambiguous case loft signs. Who did I? Yeah, I like these people. Yeah, these people are cool. Yeah, here we go. Yeah, this was it. Yeah. So here's the where do they put ambiguous case? No triangle exists. 2 different triangles exist, right? Yeah. So this is kind of what they talk about. Yeah, okay. You can either have the acute angle or you can have the obtuse angle. Yeah. Oh, that's cool. It's something like this. I also like what is going on here, dude? Like what is this? If you're in control, if this is your math website, I'm really confused. Like where this image came from. Like this is just. I should make. I'm gonna make this one of our emojis. I actually kind of really like this. It's like wink, wink, hint. Too fucking funny. Anyways, it's all right. Two different solutions work here. So now we have to figure out, if this was 53.6, what would this be, right? So if this was 53.6, wait, not back to her, please. Okay. I do. What was it? It was 53.6 plus the 28, right? And then we do 180 minus that. So, no. It's actually right on the border. It's kind of cool, actually. So that would be 98.4. So one of the solutions is that this is 98.4 degrees, right? This is 53.6 degrees. And then now you have to do another law of sines here, equity, because now it's this and this. So now you just say, okay, sine of 28 degrees over 70 is equal to the sine of 98.4 degrees over x. That'll get you a solution. And then the other one was if this was 126.4. So that would be 28 plus 126.4 minus 180. So 180 minus that. And that would have your third angle being 25.6. So now I would have sine of 28 degrees over 70 is equal to sine of 25.6 degrees all over x. And so these will get you 2 different solutions for whatever this distance is. Cool. I'm not going to do the math. You know how to do the algebra, so you're good. Does that make sense, equity? It's kind of a cool one. Yeah, kind of. Okay. Well, here. Go through it in class tomorrow. And then if it still doesn't make sense, ask me again on Monday. And I'll explain it more to you. But this is a good thing for you to see it for the first time. The important thing is, I want you to understand this. I want you to understand that when you take the arc sine, that you can get 2 different angles. And that the one the calculator gives you, there can be another one that the calculator is hiding from you. Does that make sense? Did this explanation at least? This is the important thing that I want you to know. Is that taking arc sine with a calculator only gives you one solution when there can be a second one. Yeah. Oak Spirit says, does anyone know how to perform vector phasor calculations in polar form in degrees on a TI-84? I've only been able to do it in radian mode. I tried this and could not get it to work. I'll check it out. But yeah, good question. Okay. Here, I'll give you points. Okay, what is this? Agree. Well, because I love the. I mean, you saw I have my calculator. My calculator is right here. But yeah, let's phasors. That's a lot of that's electrical engineering stuff. Okay. One sec, Ethan. Okay. Yeah, using it for circuits. Okay. Does anyone know how to perform in polar form in degree? So you can't really. Yeah, this is all in radians too. This has to be in radians. You know why this is? It's because it's e to the I theta. And when you're doing e to the pi I, all that stuff, they do not use degrees. They don't. Actually, there's a very cool person in our group of math streamers. Here, I'll shout him out. what is it? E to the, oh, he's not in here, so I can't do it. Okay, whatever. But yeah, e to the 2I pi. Yeah, and that's just how like math works with e. Well, okay, so if you want to put it in degrees, just convert things to radians. Yeah, I don't think you can do e to the theta I in degrees. I just don't think that works. Because I mean look at this, right? Let's do like, for instance, e to the pi times where's I? Right? This should give me -1. Wait, why is that not working? Second I? No, what? No.
Actually, what is that calculator?
There we go. This will get you -1. Okay. Oh, he says this shows it in degrees. Yeah. Do you know why? Okay. Look what he's doing here. Okay, watch. Let me show you. He's taking look, 40 pi dividing by 180. He's converting this from degrees to radians. Yeah. Like this series of keystrokes right here, Oak Spirit. Like it says press 40 second pi. That's so he's taking 40 degrees, he's multiplying by pi over 180. Yeah, that's okay. Yeah. See here? Yeah. So this is in degrees. But his final answer is 59.37. Yeah, that's not in degrees. That's in radians. I think. Is it? Or maybe that's in degrees, right? That would be weird for you to put it in radians here, but then it spit it out here in degrees. But also 59.37 is 1 sec. Maybe you're right. Well, here let's do an easy one, right? What's an easy phasor calculator? Let's just test it. Phasor calculator. Phasor. What are we doing? Are we multiplying 2 phasors? Is that what we're doing? Or we're adding 2 phasors? Okay. Adding phasors. I'm just curious. Okay. This is what I like to do this. Like, I just see an example one. It's actually kind of a cool page. Here, let's copy this in. I've actually wondered this myself because I've had to use online calculators to help kids with electrical engineering homework. I didn't know you could do phasor stuff in TI Calc. That's pretty cool.
Wait, what's TI Calc?
TI Calc is the TI-84 language that it uses. What's up, not your friend?
Okay.
Okay, so here, so what we need to be in normal, degree, and RE to the I5. I think that's it, right? Yeah, I think that's all we have to be. That's the only. Okay, so 1 sec. Let's put those modes on. So okay, mode, right? Degree, and then RE to the I5, right? That's what we need. I think this is okay. Okay, cool. So if we wanted to add these two, right? That would be, and then how's he doing this? Degrees, okay, cool. Or he just says e to the x. Okay, cool, got it. And then 12 is the, 12 is the magnitude. Okay, I gotta remember my electrical engineering. Oh, is it? Okay, then maybe it does. Well, that's kind of weird that you have to put it into radians, into the e to the x stuff, but then it outputs it as degrees. That to me doesn't really make much sense. But here, okay. So let's try adding these, right? Which would be, Mathematica defines constant degree as pi over 180, so 60 times degree converts to radian. Okay, well, let's do it on these steps. Let's try to do this question. Do you see this one, Oak Spirit? So we're doing 15 60 degrees, adding to 30 negative 50. So let's just try to do it. So I think it's just like 50, right? And then if I'm converting this into radians, this is going to be 60 pi over 180, right? And then we're going to add this to 30, E, and this is going to be negative 50 pi over 180. Let's see what we got. I'm just curious. Okay, well, that's not the mode I wanted. What? Where's the... Is there some other mode I need? One sec. Let's see. Normal. Let's just make sure we're all in the right modes here. Full. I don't know, he puts it on float 2. Maybe float 2 is what we want. Functions fine, sequential, connected. Yeah, I don't know what else is weird here. Normal, fixed 2, auto. Yeah, auto. Math print, cool. Yeah, so this should be fine, right? Yeah, so why did this not come out nice? Eh. This one does it really nicely. It gives you the E to the whatever. It may be okay. You may not have the most recent firmware. Okay, so here, let me try it on this one. Like I have an actual TI-84. So one sec. Yeah, okay. Let me try it here. 50. Where's the E to the? Either 60 pi divided by 180 plus 30 e to the negative 50 pi over 180. Now that also doesn't come up. What are they doing differently here? Math print, normal, float, okay. 2 radian degree, function, thick, sequential, REI thigh, yeah, full, cool, answers auto. Go to second. Stat diagnostics. Okay. Oh, I did 60. Oh, sorry. It should have been 40. Yeah, my bad. Well, it's still not getting me a number I want. I still want E to the something. But you're right. I'm doing this on my calculator, and I still don't get the same thing they're getting. E to the X, second I. Yeah, what? Oh, I forgot the I. Thank you, Jeff. Jeff, you always save the day, dude. Shout out to fucking Jeff, dude. Jeff always saved my ass here, dude. Thank you, Jeff. Yeah, okay. Yeah, so we need an I in here. Yeah, we need an I. So here, insert the fucking I. There you go. That's what we needed. My bizzles. Okay. There we go. Okay. Is that what we were supposed to get? Yes. Yeah. Do you see that? 48.7 and 24.65 degrees. Yeah. That's it. Okay. Okay, so note to self, just don't forget the I. But yeah. Okay, that's cool. So yeah, you put it in terms of radians, but then it outputs out in degrees. So wait, I'm actually curious, like, what happens here if I put this into radians? Is this gonna change the answer? It does. It's very cool. I think I might have to update my firmware. For me, it says domain error, but the same expression works in radian mode. Yeah, maybe. Yeah. Very cool. I see. So you just changed the mode, but you still need the input to always be in radians. Yeah. Very interesting. Cool. I didn't know you could do that with phasors. That's very cool. I kind of like that. Didn't know I could do phasors in my calculator. Cool. Thanks for teaching me something. Nice. Good job, Oak Spirit. Yeah, gonna be doing a lot of favor. Yeah. So Oaks Fair, did you know we have a guy who does a lot of electrical engineering help here on Twitch? If you need help with electrical engineering, I know like up to maybe like the first couple weeks of electrical engineering, and then like I don't know, it starts getting like weird. Okay, here, yeah, let me shout him out. So it is. So if we go to math streamers, do I have Merryweather in here? No, well, cause yeah, I guess he's not really a math streamer. But one sec, let me pull his page up. Sorry, it's Merryweather. There we go. This is him. There you go. So, go follow that guy, Merryweather. And if you see that he's online and you have any questions about electrical engineering, tell him Dr. Gold sent you, and yeah, go ask him. He has a full electrical engineering degree, I think. My PhD's in plasma physics, so I did a fair amount of electrical engineering, but once I get like into some of this harder stuff, it's a bunch of like shortcuts and tricks that I just didn't learn. Yeah. Oh, you're talking about another chat. Okay, good. Cool. Then you already know who he is. Great. Awesome. Cool. Good stuff, man. You're very welcome. All right, cool. All right, good to see you, Equity. All right, who am I helping out next? Bob? Bob, you need help? Yeah?
Uh-huh.
Uh-huh. Wait, your answer was wrong, dude? The one you got on that?
I asked her a few times, she said it's wrong. Because she said her only hint for me was to find another function to multiply arctan with, but nothing looked no.
Wait. So why do you think you lost your A? Because you don't think you're gonna get enough partial credit from her, or like what?
No, because her grading system is she has 10 learning objectives, right? And then
yeah.
And then so there's each learning objective has 10 proficiency problems and 10 mastery problems. And then you need all proficiency points for a C and all mastery points for an A. And that one.
Dude, wait. You have to get them all right. Like just straight off the bat, if you don't get all the mastery questions right, you don't get an A in the class. Are you serious?
She gave us on quizzes. She gives us 3 chances on quizzes, so 3 different weeks, and then she gives us a test on the midterm. And then this week, so it's my 5th try, and I still couldn't get it. So I guess it's fair, but at the same time, it's just wait. There's some things that I've messed up on.
Does she give you the same question, or she gives you a different question every time?
Different, and usually it's and sometimes completely different.
Oh.
But within the same learning,
Bro,
the
same
series,
topic,
right?
Yeah, same topic.
It might be it might be find what this converges to, and then next one, and then the next quiz will be for the same learning objective will be what's the error term, or it's just something different that I wouldn't expect or something.
Bro, this sounds like the Hunger Games or something.
Yeah.
Why is she this is the weirdest grade.
I'm definitely gonna give a 1 out of 5 on Rate My Professor.
Yeah, dude,
5
fuck her,
difficulty.
No.
And all of her, she's received 5 so far this semester already, and all of them are bad.
Oh my god. Okay. Well, it happens, man. Don't let one bad teacher in college discourage you. It's okay. It happens.
But I need to get learning objective 10 proficiency tomorrow.
All right, let's do this one. Let's do this one. So this is what happens. Okay. So a spring has a natural length of 30. Suppose 2 joules of work is needed to stretch the spring. How much work is needed to do? Okay, first of all, F is equal to kx, right? Well, and so x is the distance from the distance from the equilibrium, which you're doing okay here. What's wrong with this, dude? What? Well, first of all, it's okay. It's k times x. So it's the integral of 0.05 to 0.1 of 6 times x.
Oh, really?
Hey, you just did 60x. You need 6x. Because then the energy is going to end up being 1/2 kx squared. Well, okay, no. This is wrong, first of all. This is wrong. Okay. This is wrong. So let's do this first. Okay. Okay, you need to determine k, right? Which to do that first, you use an initial condition here. So let's just come up with a general equation for how much energy you get from stretching this thing, right? Okay. So if I stretch something, right? Let's just say in general from A to B. that's going to be equal to 1/2. That's equal to k, and then it's x minus a, right? Dx. Or sorry, no, sorry, it's just. Sorry, what am I thinking here? No, it's just kx. Yes. Yeah, kx. I mean, I could do this. I could say this is equal to kx minus 0.3 dx. That way, these are absolute distances. Does that make sense?
Where do you get to 0.3?
Because that's the natural length. So the equation is right.
Yeah.
F is technically equal to k delta x, where this is x minus x initial, and this is like the equilibrium length, right? This is a physics term actually. So equilibrium is 0.3. This is what you're going from, and you're going from A to B. Okay. So when you integrate this, you end up getting 1/2 kx squared minus what is it, 0.3 kx?
Yeah.
And then that's evaluated, right, from A to B. Okay. So that becomes so when we evaluate that, right,
1/2 kb squared.
it becomes 1/2 k, and then we're gonna say b squared minus a squared, right? And then it's minus 0.3 k, and then it's b minus a. Okay, that makes sense.
Yeah.
I think that does, right? Plus a, yeah. Okay. Minus.
I think it's right.
Yeah, I think it's right. Okay. So, I know that this is equal to 2 when what is it? When A is equal.
Is it 2 because of 2 joules?
Yeah, 2 joules, right? When A is equal to 0.3. Oh wait, sorry, we forgot the. Yeah, that's okay. A is equal to 0.3, and B is equal to what is it? 0.42. Right? When I stretch from it says stretch to length of 42, I'm going from 30 to 42. Okay. So now you can just like you can plug this in to solve for k, right? So this is 1/2 k, and then this again. This would be so much easier to do with just physics, but I get it. They want you to do it the calculus way. Like I would just say 1/2 kx squared and be done. But they want you to show your work, I guess. So this is 0.3 k, and then this is going to be 0.12, right? It's equal to 2. Okay, so I don't know. I can do some math here.
This is so hard.
It's not hard. It's just unnecessary, is what it is. But I don't know like how much of a stickler your teacher is, right? So whatever. Let's just do some things. So 0.42 squared, right? Minus 0.3 squared. Is that times 0.5, right? So we get 0.0432 at k for the first one. So I have.
Wait, is there an easier way to do this? Because we're not allowed calculators in the test.
You're not allowed a calculator on the test?
No.
Oh, okay, cool. All right, let's do the easier way then. Sure. Okay. Integral. I'm just gonna say this. Integral of kx is equal to and then it's from a distance. So we're gonna say from 0 to, in this case, it's just gonna be 0.12, right? Is equal to 2. Okay. Because we're going from equilibrium to 0.12. So cool. I just get that 1/2 kx squared from 0 to 0.12 is equal to 2, right? So that's 1/2 times k times so this is 12 over 100 squared. So that's 144 over 10,000. Or 100 squared is 10,000, right?
Yeah, 10,000. 4 zeros.
Right? Yeah. Yeah, okay. Is equal to 2, right? Multiply by 2. So k, so you end up getting that k is equal to 40,000 over 144. So if I'm not allowed to use a calculator, right? Okay.
Yeah.
Cool. All right. So then I need to do it from 35 to 40, okay? So now I'm doing 1/2 kx squared. It's the same equation, right? But now we're going from 0.35 to 0.40. I feel like you need a calculator for this, dude. What? I don't know what 35 squared is.
Wait, can I show you an example of how she did these before?
Yeah, sure. Show it to me, dude.
Can't find it.
Oh, it's not 35 to 40. Sorry, I'm dumb, dude. No. We're easy. Sorry. It's from 0.05 to 0.1. See, this is where I'm getting confused. Because it's going from 5 centimeters from equilibrium to put. Thank you, Jeff.
Yeah.
Another save from Jeff. Yeah, this is easy. Thank you, Jeff. Jeff's always got my back, dude. Okay, so this is not too bad. So this is gonna be 1/2. I'm gonna say 4 times 10 to the 4th over 144, and then it's going to be 0.1 squared minus 0.05 squared. Okay.
Mm-hmm.
So that's going to be 1/2, 4 times 10 to the 4th, all over 144. So that's 0.01 minus 0.00025, I think. Because what was that? That's 5e to the minus 2. So that's 20 times, so that's 25 times 10 to the minus 4. Right, that's 0.0025. Yeah, okay. I think. Right? 5e to the minus 2. Yeah. Yeah, 25 times 10 to the minus 4. And then that's 1 times 10 to the minus 1 times 10 to the minus 2. Okay. I could keep it all in fractions. You know, Jeff, I could, man. Yeah, you want me to keep in fractions? Let's do that. Let's say 1/10.
Well, I just post this how she did it.
All right, post how she does it. Okay, so this would be 1 over 100 minus 25 over 10,000. Where'd you post it in? Oh. Mm-hmm. Yeah, it's the same thing.
Hey.
Yeah.
Yeah, like, what's the trick behind the units?
Okay, so she says a 20 Newton force is required to hold the spring. That's different. This is 2 joules of work is required to stretch. Work required to stretch is different than force required to hold. Force is kx. Yeah. So in her dude, she's a real bitch.
She doesn't even show us these.
Yeah, because
Like,
she's
all these examples.
yeah, because she's switching it up.
And I'm not even a physics student, so like I don't even know how to do half of. I don't even know how to do any of them.
Okay, well, I mean, I guess maybe you should have learned this in your book, right? Maybe. I don't know.
I don't know.
Anyways, okay, this isn't.
She never told us to read the textbook.
Well, you should probably, because this is definitely covered in it. All right, so this is 4 times 10 to the 4th, all over 144, and then this is a 0, a 0, a 0, a 0. So this is going to be times 75 over 1 times 10 to the 4th. Oh, this is pretty cute. Watch how this works. It's kind of cool. So
10 to the 4th.
10 to the 4th cancel with 10 to the 4th, yeah. And you end up getting so this is 150. So the 4 in this cancel to become 2. 2 times 75 is 150. And you get 150 over 144, which you're right, Jeff, is 300 over 288. I can drop it down even more, right? That's 75 over 72, which I think I can drop by 3, which is then 25 over 24. Right?
That was fast, man.
Yeah, there you go. Yeah. Well, fuck her. Dude.
Wait, what would be a unit?
Oh, what are the units for that? Units for that are joules.
Like, how do you know how do you find the units?
Well, you have to know what the units are. So first of all, it said how much work is needed, right? Did you see how she said 2 joules of work?
Oh, so you just assume it's joules. Okay.
Yeah, just assume it's joules. I mean, usually always is. Dimensional analysis. Oak Spirit is right. Yeah, you could use dimensional analysis, but this is a calculus class, so they're not really expected to know the physics. You're right. I would have just jumped straight to 1/2 kx squared, and I would have just done, you know, which is kind of what we did here. We did like 1/2 kx squared, right? Is this, and then we did the difference between the two. But yeah, it's a lot of, yeah, not using a calculator. It is cool how the numbers work out eventually, but it's, you know, it's kind of a pain. Cool. Does that make more sense, Bob?
Yeah.
Good.
Thank you.
You're welcome. I'll send you the file.
Here you go.
Bob the Goat. Okay, cool. All right, nice. Here, let me help out. What's your name again? Ask something, dude. Like what? You have a very unique name. Asadikaj05. Are you here, Asadikaj05? You want to come and speak? Sadikaj. I tagged him. He had some physics questions. Oh, nice. On stage. Cool. All right. Yeah. Here, I'll go ahead and do yours real quick, because I know you. I'll do one of yours for now, and then if I have time, after going through other students, I'll go through the other ones. Let's do the two-star question, because this is probably the harder one for you, man. Yeah. So for those of you that are in like physics classes or anything, and you've hey, what's up? There's Zach. You know what we were doing earlier, Zach? We were doing actually, we were doing phasors. I updated the firmware and still get the phasors working degrees. I'll just do radians though. It's fine. Yeah. So it's funny, Zach. I was saying I wanted to tag you because like we were literally using your name. We're doing e to the pi I. We're doing phasors on the in vector calculations in polar form on the calculator. Yeah. Oak Spirit, you want to like take a screenshot? Oh yeah, the AB notation is actually used by engineers. It really is. Yeah. It is. I've had to help a lot of students in electrical engineering, and they use that notation. Yeah, no, dude, a lot of things in EE are pretty archaic, but it's just like how they do it. Yeah, they didn't get the firmware update. Yeah, I like how you know how to do that notation though with the text. That's pretty cool. Yeah, Oak Spirit, send me a screenshot of like what you're doing on your calculator. If you can like take a picture with your cell phone, I can like maybe see if something's wrong. ASCII art, yeah, we love ASCII art. Someone was sending me some like weird ASCII art. One second, let me find it. What page was it on of mine? Oh, I'd have to log in again. Oh, I don't really want to do that. Yeah, never mind. Okay. Asadikaj, what do you want me to call you, by the way? Like, what can I...
I told you before. Andy.
Andy! I like Andy. That's
Yeah.
such a easier name. Like, where does the Asadikaj thing come from?
Oh, it's my last name.
Oh, that's cool. You have
You have
a very unique last name, dude. That's cool. Okay, cool.
I haven't met anything else with it.
What was it? Oh, this was it. Okay, this was one sec. I gotta show the ASCII art that I got earlier from someone. Like it was quite strange. Someone sent me this. They said I forwarded it to myself. They say if you were killed tomorrow, I wouldn't go to your funeral because I'd be in jail for killing the mother that killed you. we are true homies. We ride together. We die together. Send this gun to everyone you care about, including me if you care about me. See how many times you get this. If you get 12, you're a true homie. First of all, they didn't spell "your" right. God damn it, these people. I don't know. I thought it was hilarious. But this is ASCII art. For those that don't know, this is what ASCII art is. Yeah. Kind of weird. All right. Here, let's talk about Andy. The fuck is that? I don't know. We call it copy pasta. Okay, cool. Thanks, man. Yeah, I'll check it out. Looks great. Oh, I see.
This is the issue that I have is the like when you start applying kinetic energy to stuff, like my brain stops working, dude.
Oh, it's okay, dude.
Like
We got it, dude.
same thing with like the
Same thing with what?
for conservation of momentum. That was
Yeah.
like the chapter after this. Like I'm preparing for exam.
Okay.
It's on work, conservation of momentum, and then this stuff.
Yeah.
And
So
every time we have friction, I just lose it.
yeah, okay, because friction is like an additional thing that kind of like you have to add into the conservation terms. So just as like a quick little refresher here, okay? If you have for instance conservation of energy, right? So you have like I usually say there's like situation 1 and then like situation 2, right? And what you're going to do is you're going to calculate the kinetic energy, you're going to calculate the potential energy, You're going to calculate the kinetic energy. You're going to calculate the potential energy, and then you're going to get a total here, right? And that has to equal the total here. Yes?
Mm-hmm.
Okay.
Yeah.
When things undergo like friction, like going from situation to situation 2, like for instance, from where it starts to where it finishes, you have to also add in the work done by friction. Okay? That counts as like an energy term.
Mm.
So here I would say work done by friction. And I put that on this side is what I do. And I put that as a positive number. Because it's like, okay, cool, we have energy here, and we also have some energy that went to friction. But we don't see it anymore. It's like it's gone. Okay? Okay, cool.
And so you put it as a positive?
I do. I put it as a positive on the right side. That to me makes the most sense. So it would be a negative on the left. But usually, like, friction is happening as you're going from here to here. That's usually what happens, right? Situation 1 in this case, right, is that the block is sitting still here. Situation 2 is that it's ending here. When we went from here to here, I assume we're going to hit some, like, friction here. And so that energy is still in the second situation. It's just being stored in this imaginary, like, friction land. So that's why, like, I put it here. Did you ever have conservation of energy explained to you like as a bank, right? Did they do that for you? I don't know. They might.
No.
Nah. Okay. Well, I feel like this way makes the most sense. But you know,
I've never heard of that.
You never heard of the bank? Okay, it's okay. So I like to think of conservate, like you have like different accounts is what you have. Okay. So let's say, for instance, this is like kinetic energy. And then this is potential energy, which usually they write as UE. And then, so, right, if something has a lot of kinetic energy, but then starts to slow down, then its potential energy is probably going up. Oh, thanks for the follow, guys. Or thanks for the resub. Oh, wow, we got a sub. Oh, thanks for the sub, dude. But the total amount of money in the bank is the same, Andy, right? So, like, if this is like 3 and this is like 6, cool. And then let's say kinetic energy goes up. That means potential energy must go down. So this could be like, for instance, like 5 and then 4. The total is still 9.
Yeah.
Okay. So here, I'm not even going to read the question. I'm just going to assume that we have a block here that's stationary, and then it moves, right? And then it stops, okay? So how that works is that at the beginning in situation 1, this thing has all potential energy, right? And like basically no kinetic because it's not moving. It's at rest. Yeah?
Yeah, I hear you.
Okay. So then this thing falls down the ramp, okay? Which means it's going to lose all of its kinetic energy, all of its potential energy, right? And it's going to convert it all into kinetic. But the total still has to be the same, yeah?
Mm-hmm.
Then this thing is going to start moving across friction, which means that there's now a new account in our bank that gets opened, which is the friction account, okay? This is what I would call like work done by friction, okay? Because now what happens is, even though the potential energy is not changing, the potential energy is still staying at 0. Now I'm losing kinetic energy and I'm gaining what's like friction energy. Like the friction account is robbing all the kinetic energy out of my block. So that eventually when this thing stops, okay, my kinetic energy is 0, my potential energy is 0, but all of my energy is now in friction.
Okay.
Does that make sense?
So is this connected to like questions that talk about energy dissipation?
Yes. Yeah, anytime you have energy lost in a system, that becomes part of part of this extra term. So actually I already see what's going to happen here. This is actually going to be a 3 situation problem, okay? We're actually going to have 3 situations, okay? We're going to have like situation 3. KE, PE, and then work done to friction. Say work by friction. Because here's what happens. So block starts here, right? It's going to have all potential, very little kinetic, right? And then it's going to be here at situation 2, where all of and first of all, this has no friction while any of this is happening, okay? So then this is going to happen, okay? And then and that's right before it starts hitting the rough spot, right? And then at this point, right, that's going to be situation 3 where this all drops down and then this all comes back up.
Okay.
Okay?
Yeah.
Okay.
Hmm.
Also, yeah, little hint for guys. If you ever like, do you know what these 2 dots mean on your homework?
Like when it's harder, like the
Good,
multiple
yes.
dots are like
Yeah.
if there's 3, it's
The
harder.
more dots, the harder the question. Some kids don't know this because I guess they don't really use textbooks. But I was like, yeah, anytime you see like more dots or stars or things, usually means it's a harder problem. So if you're looking for like hard questions to prep for an exam, look for the ones with the dots and the stars. Yeah, they don't really teach that. It's kind of weird. Okay, but here, let's like actually do this question. So I'll put on a new page. Okay, it says 2 kilogram block. Sounds okay. Height of 3. Block slides 9 meters on a rough surface before coming to rest. What was the speed of block at the bottom of the ramp? Okay, so they want this, right? So this is situation 1. This is situation 2. And this is situation 3. Okay? In the beginning, right, my kinetic energy is equal to 0. My potential energy is equal to mgh. So that's mgh, which is going to equal to 2 times 9.8 times 3. Yeah?
Yeah.
Okay. And then nothing else has happened, okay? Situation 2, now my kinetic energy, which is equal to 1/2 mv squared, will be maximal, and kinetic energy will be equal to 0. Okay? Does that make sense?
Oh, okay. Potential energy. Yeah.
Potential energy drops to 0 because now my height's at 0, and then my kinetic energy is 1/2 mv squared. I know right off the bat, right? Here, I'm gonna be just because I don't want to use my calculator as much. I'm just gonna call gravity 10. Don't hate me. I'm sorry.
Engineer.
I know.
Engineer mindset.
I want to make this quick so I can help you with more questions. But yes, so this is gonna end up being 60, right? So this total is 60. So that tells me here, right? The total also has to be 60, which means that 1/2 mv squared, right? 1/2 mv squared must equal to 60. So 1/2 times 2 times v squared must equal to 60. This goes away. So that gives me my velocity at the bottom equaling the square root of 60.
That's 7.75.
7.75? Cool.
Okay.
That makes sense?
Mm-hmm.
All right. So that's part A. Part B is what is the energy dissipated by friction? Okay. So now I know that it has to go across here and it has to drop at situation 3. Kinetic energy is equal to 0. Potential energy is equal to 0. But the work done by friction, right, which is going to be equal to the force of friction times the distance, which is equal to mu k Fn times the distance, which is equal to mu k mg times the distance.
Okay.
That's also going to have to be equal to 60.
Oh, okay.
Total has to be 60 everywhere, right? Yeah. Okay, so in this case, do they give you mu k, or we got to solve for it?
No, you got to solve for mu k.
Fuck.
What normal force is 20 times a distance of 9. That's
Oh, we already have the distance. Oh, my bad. Yeah, cool. Yeah, all right. So 60, right, is mu k times 20 times 9, so what? 180, right? So mu k is equal to 0.3.
Okay.
0.33. 3333. Whatever. Yeah.
So
Cool.
if the whole plane was with friction, so starting
if this was from here?
Yeah. I had a question like this in my quiz. It was talking about the normal force on that side part.
Yeah.
So I'm saying if there was friction throughout the whole thing, do you know how to get through that type of problem?
You can't. You can't because the normal force is changing.
Okay, so how do you find that
because
force initially?
This is because this is circular motion, right? So the value of this normal force is changing as you move down the ramp. Because there's technically a v squared over r acceleration, and v is also changing. So yeah, this sucks. Like you really shouldn't do that.
Just maybe.
You can approximate it. I think you can approximate it as being like, okay, whatever, the normal force is just mg. It's not, though. Like, this thing is going to not have as much friction. I mean, it makes sense, right? This thing is not going to have as much friction up here as it will down here. Because yeah, the normal force is quite light up here. The normal force becomes quite heavy down here.
All right.
Yeah.
So if okay, so you said it was the MV was MV squared over is it R? No.
Oh, if you want to figure out the normal force, well, also I need like an angle at this point too. I need a lot of things for this.
Oh.
Right? Because here,
our question was
yeah. What was your question? Do you have it?
no, I don't know off the top of my head. It was a bowl at a mass of 0.4 and it had a radius of 20 centimeters.
Mm-hmm.
And I was asking like on the edge of the bowl, what
Oh.
was the normal force? I ended up solving for the velocity. I got like 2 meters per second. But I didn't know to make it equal to the what's it called, the centripetal acceleration.
Yeah. Okay. So you had something like this, I'm guessing.
Yeah, and then the edge of the bowl, so it was like a massive point. It was like 4 grams.
Okay.
Yeah, and then with a radius of 20.
Meters or centimeters?
It was centimeters, but it doesn't.
Okay, so
really
0.20. Yeah.
And then I ended up solving for the velocity.
Oh, and then it's moved. Okay. Okay, I see what's happening here. Do you have the coefficient of friction?
No.
They didn't give you a coefficient of friction?
You had to find it out later.
Okay. Well,
they gave it to you like later, but it just said the normal force in the beginning.
Okay. Well, the normal force is this, right? Yeah, this is force normal, which is going to equal to in this case it's the mass times the acceleration in the x direction, right? In this direction, and I assume this thing is like rotating like this way, like into and out of the page, right?
Yeah.
So that acceleration in that direction is centripetal. So you just get that Fn is equal to mv squared over r.
Mm-hmm.
Okay. Now, once you have that, okay, now you have a force diagram where, like, force of gravity is pulling you down, but the force of friction is keeping you up. Okay? So in order for you to not fall down the bowl, I need the force of friction to equal the force of gravity. Force of friction, right, is going to be mu k Fn. Force of gravity is equal to mg. So now this is mu k mv squared over r is equal to mg. The cool thing here is the masses cancel out. You don't even need the masses at this point. So yeah, so now you get mu k is equal to gr over v squared.
Okay, that's what the question was about.
Yeah.
I think we're good.
Okay, cool. This one makes sense, yeah, too. Yeah. Let me go through some of the other people's questions, and then if I have time, I'll do that other one you wanted help with, which is the
I just need to understand what the I just need to understand the whole friction connection to it. I didn't know that was like a whole separate force because I was thinking of kinetic energy equals potential energy, and I didn't consider the work done by friction.
Oh, perfect. Yeah. It's just another energy sink. That's all it is.
All right, perfect. I don't need the other one then.
All right, cool. All right. Well,
all right,
yeah.
Thanks, dude. Have a good night.
You too, man. Good luck on your test, bro.
Perfect. Thank you.
Oh, he has a couple accounts. They could have spelled "you're" wrong. Yeah, they definitely could have. Sensation, couldn't they, dude? What the hell?
Good evening.
Good evening, chaps. Did you just wake up?
Yeah, just about.
Hey, just about. How was Deus Ex last night?
Oh, I finished it in the end.
Oh, did you? What's the amount of hours for that playtime? How long does it take to get through Deus Ex?
I think if you speed on it, you can probably do it in a couple of hours.
Oh, that's not bad. Okay.
I think it took me like a week.
Oh, yeah. All good. What were you going to say, though, Sensation? Sorry, before I cut you off.
Oh, I don't know whether you covered this before, but I wanted to say...
What's up?
How can I phrase this? Energy cannot be created or destroyed. It can only
Correct.
be transferred from one form to another.
100%. Yeah.
I don't know if you covered that already, but that's kind of what you were saying.
That's exactly what I was, that's what I was going over here when I was drawing. Where's my bank, dude? I need to make a TikTok out of this. My bank of energies. But yeah. It's just, the total energy in the system can't be like taken out or added, but it just gets transferred between all the different accounts. That's how I describe it. Yeah. Yes, sir. Oh man, who else we got today? Consolation homework. Oh wait, that was equity. We got Saint. Is Saint here? What's up, Saint? Saint in the hat house. Where's Obama, by the way? Obama, how did your quiz go? How did your quiz go, bruh? And then I got Taco Cat and I got Nick. Sorry, Nick, you were saying something? I never learned that. I learned Lil even though I don't understand the formulas. Saint is here. Let's do Saint's question. Yeah, cool, dude.
Loading.
Oh, he's doing... Dude, Saint, bro. You know how to do this, bro. Dude, I'm going to make this harder for you, dog. Oh, your Wi-Fi turned off? Okay, well, I'll do yours next, Nick. Don't worry.
Yo.
Okay. Yeah, what's
What
up,
up?
Obama? Obama, how's it going, bro?
The quiz back. Yeah.
Yeah, you haven't gotten your quiz back?
Nah, she takes actually.
She
yeah,
hella
no,
lags, dude.
No, it was a test, so she takes a bit longer, but she's
Oh,
pretty
okay.
fast. Maybe like 2 more days.
I'm glad you
I
at
have
least still
100
get your...
right now.
Oh, dude,
Pre-cup.
nice.
Let me see your-
That's sick.
Yo, you said shut up, bro. Yo, shut up, Sam, bro. Damn.
Yo, shut up, Saint. Yo, dude, the
Look.
boy's got 100, dude. Let's check this out, bro, dude. Yes, dude. Yes, look at that. A+, 100, 10 out of 10. Good job, Obama.
Get in some.
Getting some, dude. Wait, your teacher's name is Yao Shu? How do you pronounce your teacher's name, dude? What? Yao Shu?
I
Yao
don't
Shu.
know.
Yao Shu.
I call her Miss Du, but like obviously I'm pronouncing it wrong. But I don't. She doesn't care.
Yeah, that's something Chinese.
Cause I don't do it on purpose. I'm just not good with that, and I don't remember every teacher's name that good.
I know. Oakspirit says I have a 40% in Diffie Q. Oh no, Oak. Oh no. You should get help. Get help on the stream. I can help with some Diffie Q. E to the Pi I who popped in here earlier is probably better at teaching Diffie Q or Pen Center. Pen Center is really good. Oh, I was gonna check out your calculator thing. Well, here, let me do Saint's question real quick, and then yeah, I'll check out your calculator thing where that's wrong. Oakspirit. Okay, Saint. It's all right. I got it. You know how to simplify this? Okay, but let's make this a little bit harder. Okay, I'm gonna make something harder for you. Yeah. Okay. Let's say I have what do we want to do? What do we want to do? 3, 3. Yeah. Let's say we say 243 to the 2/3. Ooh. No. Let's do this. To the 3/4. Ooh. How do we do this? You know how to do this. I know you know how to do this. Please tell me you know how to do this.
See,
Yo,
I
go
started
do-
getting these questions for hire.
You should be able. You should. Yeah. You know how to do this question, Sensation, right? Do you know how to do this one? You know how to do
Well, the weird
64 to
thing
the
is
1/2?
They're not supposed to turn up, but like they've started teaching it in higher GCSE. These
Oh,
kinds of
yeah.
questions. And it's like, well, have you ever actually seen one of these in an exam? And like, no, it's way too high. But
Well,
you
yeah.
always
It's
do it anyway.
it's just a different way of writing radicals. That's all this is, man, dude. Like it's not that bad. I get it.
I totally get it now. So
You get it now. Okay, good. All right, so let's teach the boy, dude. I didn't have
No
school
spoilers.
yesterday. I didn't have algebra today. Okay, well, okay. Anytime you got something like this with like something being raised to a power and the power is a fraction, the top thing is. Well, let me explain why this works. Actually, this is pretty cool. Let's say, for instance, we had 64 to the a over b. Okay, you know this is the same thing. Like let's think of ways. What are some ways I can write a over b as something times something? How can I do that, Saint? How can I write a divided by b as something times something? A times b? No. Close. A times b would just equal to ab. I want a over b. How do we get a times something is a over b? This is very important to know. It really is. You don't know? Well, it's okay. Your brain is fried. Uh-oh. Okay. This is the same thing as a times 1 over b. Okay. A over b is equal to a, right? A over 1 times 1 over b. Yeah, long week. Yeah, I feel you, dude. It's okay. But we can do this at least, right? Okay. So this is the same thing as 64 to the a times 1 over b. Okay. Another way to write this would be 64 to the 1 over b times a. Yeah, close, Nick. It was close. you can always swap these. You can always swap. Like AB equals BA and ABBA. I don't know, there's a song there or something, but yeah. So here's the other rule we need to know. Do you know how to write 64 to the A to the B? Do you know how to write like a power to a power? Also useful things to know. Okay. This is equal to 64 to the A times B. Okay. So, do you notice a pattern here? Yeah, you forgot all this, Nick? Well, listen up. Don't forget this shit. You have to know this. Look at this. This is A times B, right? This is something times something. And remember, if something's times something, it's like raising to the power to the power. So, if I wanted to, let's just put this over here, rewrite this, okay? That would be 64 to the A to the 1 over B, which is the same thing as 64 to the 1 over B to the A. It's like the power to the power rule. Actually, we can get rid of these parentheses. We don't really need these ones. Okay.
Dark says, I have this in my 5th grade book. No, you don't.
No, you don't.
Year 12.
I don't think they're teaching you this in 5th grade, dude. What? Okay, yes. Awesome. Cool. Great. Yes. Great. Okay, cool. All right. So, next, what we need to do, right, is we need to kind of like establish some rules of what something to these different powers are. So, your initial question was this, 64 to the 1 over 2, right? What I want to tell you is that anytime you have something to the 1 over a number, that's the same thing as that number root of 64, okay? So 64 to the 1/2 is the square root of 64. By the same token, 64 to the 1/3 is the cubed root of 64. Do you see a pattern here? Right? And 64 to the 1/5 would be the 5th root of 60. Good. All right. Awesome. Okay, cool. So you should be able to do this one, right? What's the square root of 64? You gonna get it, dude? You can make me wait for you, dude. Eight. Nice, dude. Good job. Good job, dude. I'm really proud of you, dude. Yeah, good. Nice, dude.
Come on, baby! Come on! Yes! Come on!
Okay, good. It's 8. Yeah, great. Cool. Okay, there we go. Okay, it's not sending. Yeah, you're making me wait for a bit. Yeah, it's 8. Good job, guys. Very happy. Okay. Yes. All right, so let's look at this question right here, which I said was 243 to the 3/4. This looks scary, right? So I have 243 to the 3/4. All right. What I want you to remember, right, is that anytime I have something to the A over B, right, it's really either raising it to the power of A and then doing 1 over B, or doing the 1 over B and then raising it to the power of A. So this is the same thing as 243 to the 3rd to the 1 over 4, okay? So that's like saying, you know, and if you wanted to write this in whatever form, right, in radical form, this would be the 4th root of 243 cubed, right? That looks pretty scary. I don't really want to do that, right? No. What's another way to write this, though, Saint? It looks fine? No, but you can't do this in your head. I'm going to show you. You can do this in your head. You can do this in your head if you're clever. Okay? I'm not. I'm not clever. I'm not a clever man. Do you guys know that meme? I'm not a clever man. Do you know this meme sensation? Do you know that I'm not a clever man? Yeah, this is it, dude.
I don't know it.
It's a really good one.
You should not have come here, human. Why do you cross through my domain?
Here, I'll send it to you so you can listen
I was
to it.
on my way to the kitchen for a snack, and I got lost.
You ended up in the 12th plane of torment. On your way to the kitchen.
I am not a clever man.
I am not a clever man, dude. I am just not a clever man. It's okay. Anyways, what's up, Rip? Okay, so Saint, it's okay. I don't fuck with this math stuff. It's cool. I'm gonna help you fuck with it, dude. You know, I'll be like the dating coach for math. Let's try to get math to respond to a text message to take math out to dinner. Let's try that. I have an A. Well, I don't know how you have an A if you don't know how to do this, because you're about to not have an A when you take your next math class. Oh, it just takes time? Okay, that's okay. That's okay. What were you saying, Sensation?
Using A with Z.
A with Z. He's like, I have a Z, dude. Nah, it's because when we worked on this on Monday. Oh, you haven't done this? It's okay. I'm teaching you. Okay. So remember, you can either do it as to the top power first and then to the 1 over the bottom power, or you can do this to the bottom power first, right? The 1 over the bottom power, and then raise it to the top power. Do you see this? Do you see how these two things are equivalent, right? Because of this. You can either do A to the 1 over B or 1 over B to the A. Okay. This is easier, okay? Because this is like saying the 4th root of 243 and then cubing it. What you should recognize, oh wait, did I fuck this up? Wait, 3 to the 2nd is 9. 3 to the 3rd is 27. Oh, I did fuck this up. Okay, sorry. I need the 5th root. Sorry. My bad. I messed this one up. Sorry. I gave you a bad question. This is what I meant to do. You didn't see anything. Okay, sorry. I don't know my powers of 3. Okay. Is 243 is kind of, honestly, don't care. It's okay, yeah. 243 is a cool number. So let's remember, like 3, 9, 27, 81, 243. You should kind of know these powers, right? This is like 2, 4, 8, 16, 32, 4, 16, 64, 256. I forget what the next one is. But anyways, you should kind of in the back of your head know what these powers of these numbers are. So what you notice here is that 243 is the 5th power of 3. Like 3 to the 1st, 3 to the 2nd, 3 to the 3rd, 3 to the 4th, 3 to the 5th. So this is like saying, right? We already know that the 5th root of 243, that's just equal to 3. So now you're just left with 3 to the 3, and 3 to the 3 is just equal to 27. Which is done. I'm just trying to show you that, like, it's easier, right, your teacher will do this. They'll give you nice numbers that you need to realize you should do the root first before you do the exponent part. Because if I did 243 cubed, that would suck. Like, I don't know how to do that in my head. And then taking the 5th root of that, that's just a mess. Like, look, you can look this on the calculator, right? If I do, like, 243, right, cubed is like this massive clusterfuck, and then I do this to the 1/5, like, well, what came out to 27? Yes, which is the correct answer, 27. Yeah, good. It's not my fault I don't know this yet. But again, we did this for like 20 minutes. I'm not blaming you. I'm not saying it's not your fault. But we're teaching you to learn things, Saint. It's okay.
Well, here's a quick trick for a few people.
What's up? What's your quick trick, dude? What do you want to say?
Down to that power of 3, if you go back down to that power of 3 list there.
Yeah, let's go. Right here. Yeah.
So 3 is 3. 9 is 9.
Mm-hmm.
Add up the individual digits of 27, 81, and 243. What do you get?
Oh, they're all 9?
They're all 9.
Oh,
So
I
you
didn't
get to
know
a certain
that.
Point, and then they become 9s of 9s, and they become 18 in total.
Oh.
And so on and so on.
What's up, Skinny Columns Windex? Yeah, that's cool. So so Sensation actually brought up a cool thing. So yeah, this is 8 plus 1 is 9, 2 plus 7 is 9, 9 plus whatever 1 is 9. Yeah, and 2, 4, 3, right? 6 plus 3 is 9. Oh, that's cool. All the decimals add up to, all the digits add up to 9. I didn't know that. That's a really cool trick. That's like number theory stuff. Where'd you learn that, Sensation, dude?
I just, when I was about 10 or 11, I noticed that the 9 times table, they all add up to 9.
Oh. You know, I think that there's a reason for that. Anyways, good question, Saint. 10 mod 9 equals 1, thus 10 to the n mod 9 equals 1. 10 to the n mod 9. Yes. Yes. See, yeah, this when we start doing modulus stuff, Jeff, that's where like my math knowledge starts to like dip off. It's not as good. Oh, that's too funny.
Well, Here's an extra question for those that want extra credit.
Yeah, what's up?
2048 to the power of 2 over 10.
Okay. Ooh, okay, this one.
Indeed.
Okay.
Everyone's got 30 seconds.
30 seconds to do this. Oh man. Fembo says 4. Wow, Fembo's right on it. I think it's 4 too. 2 to the 11th to the 2 over 10. Wait.
It shouldn't be.
Let me see. 2 to the 11th to the 2. Oh, this is actually very cool how he's doing this. Wait, to the 2 over 10? Is this how you're doing it, Jeff? This oh wait, no. Wait. Oh, he says, did you mean 1024 to the 2/10? Well, let's see what it is. Which really is 4. No, he said 2048. One sec. Let's see that. What is 2048 to the, one sec, I'm gonna do calculator. 2 over 10. I think it was Sensation. I think it's 1024. It's a good question though. It's a really good one.
But I monumentally screw up.
It's okay. It's supposed to be 2.
Well, 2 to the 10 is 1024.
Yeah, okay, so here's how this works. Yeah, no, I'll show you why that works. Okay, so okay, if we did it this way, if we did 1024, I'll show you why this works to the 2 over 10. Okay, so 1024 is 2 to the 10th, and then you're raising that to the 2/10. Okay, look what happens here, right? Remember that the exponents, right, multiply. So this is 2 to the 10th times 2 over 10. This goes away. And you're left with 2 to the 2, which is equal to 4. I think if you said the 10th root of 2048, then yes, this would be equal to 2. But that's kind of simple, right? Because that's you recognize that 2 to the 10th is 2048. I like your original version. I like besides the 2048, but the 1024 to the 2 over 10, I think that's a really cool one to do. Or how I would actually do it, I would say to the 1/5. I would say what's 1024 to the 1/5. I think that would be a cool one to do as well. You can also add digits for mod 3 because 10 mod 3 is equal to 1. Oh, I didn't know that. Oh, there's a lot of stuff in this. Yeah, math stuff is cool. Nice Sensation. I like that. That's a cool question. Let's see.
Question that I monumentally screwed up.
No, it's okay. You know, I still learned something from it. You know. Again, nobody's perfect, man.
2 to the 10th is not 1024.
It is 1024. 2 to the 10th is 1024. Apparently. Yeah. I just did it. Right?
It's an important number somehow. Yeah.
Yeah, we all know 1024. That's all your RAM and everything. Let me see what's going on with Leo's calculator. One sec. Math is just a puzzle, Lemao. It is, dude. The whole world is a puzzle, man. Is part of the general estimate, that 2 to the 10th is the same as 10 to the 3rd. Oh, okay, very interesting. Is that also, okay. Does that also relate to logarithms? Is that what I'm also thinking, right? One sec. So if I do log base 10 of 2 to the 10th, no, what am I thinking? There's something cool here. There's something where, what is it? It's like every 3 dBs is doubling. It's more of a Gibby thing. Oh, okay. Yeah, it's kind of cool. So this is 2 to the 3rd. Or 10.
I've only just learned that term recently.
10. Gibby? Or gigabytes and Gibby bytes? What's Gibby bytes?
Yeah, because it came up in GCSE computer science, and I was like, what the hell's a Bibby byte?
Dude, what's a Bibby byte? Excuse me? It sounds like some food snack place or something. A Bibby byte?
There's a byte which is 8 bits, and then a Bibby byte is.
So a gigabyte is technically 10 to the 9th bytes, but it's also 2 to the 30th bytes. Oh, I see. Okay, that's the factor of tens. Oh, that's so cool. Okay, let's see what was going wrong with Leo's calculator. I'm just curious here. What's going wrong? Value entered is not allowed in the function or the domain Radian mode, degree mode, e to the pi over 2 times I. Oh, interesting. Wait, which one is it getting mad at? Because 40 degrees is in the domain of arctan, I believe, right? Yeah, 40 degrees is fine. So is 67. So it's oh, thanks for the follow, dude. Nice. 899. Oh, we're one away from 900. Fuck, we're so close. One away. Okay. So wait, yeah, you're saying when you run this command, Oak, so when you run this in degree mode, it gets mad, but when you run this in radian, it does not. Huh. That's super weird. Let me just see. I just want to see. Oh, I got the same error too, actually. Ooh, interesting. Wait a minute. Wait a minute. Okay. Whoa. Let's check the calculator. I want to see this. Okay, sorry. So, normal, right? Let's put it in degree mode. Let's put it in this RE to the I theta, right? Let's go up to what we had earlier, right? We had something cool. What do we have? We did it right here, right? This is what we did. And this was okay. Okay. Oh, and then let me put it into just 2 decimal mode. I'm just going to put it into 2, right? Okay, so that gave us a legit result. Okay. And so now you're saying if I put 12. Here, let's just change some of the things. I'm just curious. So we put this as 12. And then we're going to make this as 40 pi over 180. And then we're going to make this 30. Let me just leave it like this. So that still works. Okay. Let's try to work it a little bit more. Make this 67. No, that works, right? Is that what the answer is supposed to be? 12 e to the 40 pi I over 180 plus 30 e to the 60. Yeah, that's right. Okay. You know what's funny? Because I do it here on my calculator, and I get the error you're talking about. Holy shit. Wait, so like my old version of my this is an outdated firmware, I guarantee you. Like if we look at what is it, like mode, I forget how you see, like what do you do? How do you find the firmware on this? It's like second memory maybe. About, there you go. Yeah, so that's my product number. Well, that doesn't even have my firmware number. Or wait, 2.55, yeah. Bug report. Yeah, because like this works fine, but yeah, if I do it on okay, one sec. I wonder if no, see that's in polar. Damn, yeah, that's super weird. Okay. Yeah, I don't know why, because yeah, that does work on my calculator. It works on my emulator calculator, but it does not work on my physical TI-84. Which I guarantee you, like, these are... Yeah, this is a much newer one. It's all good. I'm not sure what's happening. Probably hard to figure it out. Yeah, I don't know. But I just don't understand the error, because 60 degrees is in between pi over 2 and negative pi over 2 for whatever like the domain is for tangent. So that should be fine. Degree mode, e to the pi over 2. Yeah, none of those are over pi over 2 either. Huh. I don't know what that is. Okay. Weird. Okay. Equity, yeah, what's your last minute question? Do we have any more questions in the screenshots? Let me see. What do we got? Oh, we got, sorry, Nick. Oh, Nick, we got so many questions for you, dude. What are you sending me here? 000720. Make this equation true. Am I allowed to replace the zeros with operators and numbers? Using only symbols and numbers, I hope, right? Am I allowed to use numbers? Or what are the symbols I'm supposed to use? No numbers. Yeah, what the fuck is that question, dude? What? Oh, any math symbol, just not a number. Okay. Yeah, I think this is kind of cool. Jeff, you want to take a stab at this? I'm sure you know how to do this. So we're only allowed to use symbols on this. No, you're the Jeff, dude. What? Math Jeff. I smell factorial, right? Yeah. But wait, we're not allowed to use numbers. Any math symbol, no numbers. So wait, I mean, I can't use factorial unless I have something, right? Oh, 0 factorial is 1. Wait, am I allowed to use 0 factorial? You said no numbers, though. Okay. I mean, if I really wanted to, I would say like e to the I, right? Because e to the I is 1. That's technically using, right? Can I use that? E to the I? No, but I think we're only allowed to use 1, 2, 3, 4, 5, 6 placements. I is a number. Well, 0 is a number 2. Or is it the absence of number? Aha, 0 is, wait, 1, 2, 3, 4, 5, 6. Oh, as many placements as I want. But wait, am I allowed to use 0 factorial? Is this legal? Oh. 0 to the 0. Yeah, I think Fembo has a cool way of doing it. Yeah, it's just 0 factorial plus 0 factorial plus 0 factorial plus 0 factorial plus 0 factorial. All factorialed. Yeah, because that's 5 factorial. Try to find another way. Oh, I don't know. Well, you said this was a quick question. This is no longer a quick question. Here, I'll leave the audience. The audience can like try to find another way. Let me help Nick out. Nick, what's up? You need help with this one?
No more, please. No
Yeah.
more.
No more. Okay, you and a friend toss 2 pennies at the same time. What is the probability that all 4 pennies will be tails? Okay, that's pretty cool. Do you? Yeah, this is just 42, literally. But the way to do this is, yeah. I'm coming. Okay. Are you coming to the? Oh, you coming to the stage? You coming to the Discord? Come to the Discord. Yes, Taco, you can go next. Yeah, you can go next. Taco, didn't I ask you to ask you something next time or something? I forgot. I have to go to another student in an hour, I think. Nick. Oh, what's up, Nick?
You.
Yo, what's up, dude? Okay, so this is like kind of basic probability, right? We should know how to do this. Yeah. So it says you and a friend each toss 2 pennies at the same time. What's the probability that all 4 pennies will be tails? Okay. So here's like you.
I never learned probability.
Well, yeah, how'd you take a test on it if you've never learned it?
Good question. I like how they say, if you don't know anything, it's okay. Like,
Okay.
bro.
Okay, that's not cool. Okay. All right, so you and friend, right? Oh, that is not what I wanted.
Oh.
There you go. You and friend. Yeah, you both have 2 pennies, okay? And you want them all to be tails. All right? So, this is called like joint probability, because you need the probability of something to happen, and then given that thing happens, you need the probability for something else to happen, and then something else to happen, and something else to happen, yeah. Sensation's like nodding his head. He's like, yes, joint probability. We love it. Okay. So what's the probability of you hitting tails on your first one? Like, let's just say you're 50%, right? So that's 1/2. Okay.
For me, when I looked at the question, it was like 50% times 4, no?
No, it's 50% to the 4th. It's not times 4. Well, here's the problem. Like, 50% times 4, what does that get you? 200%.
2.
Yeah, it gets you 2, which is like 200%. That's like, yeah, you can't have, yeah, no, dude.
No.
You can't have anything higher than 100% chance. Yeah. Okay. So, there's a 1 in 2 chance that your first one is tails. There's also a 1 in 2 chance that this is tails. There's also a 1 in 2 chance that this is tails. There's a 1 in 2 chance that this is tails. But what you need to happen is you need everything to happen like in succession, right? So it's 1/2 times 1/2 times 1/2 times 1/2, which is 1/2 to the 4th, which Sensation remembers is right to the 4th, right? That's gonna be 1/16.
He's actually trying.
What's he doing? What were you doing? Sensation, what was this? Were you doing like some... Oh, you were actually flipping the coins? He was actually flipping the coins?
Oh, bro, that's
You could actually go and do it. You could. Yeah. Oh, I didn't know he was actually flipping the coins. I thought you were doing like hand signals. He was like literally flipping the coins. Yeah. Oh man. Yeah, what piece is this? What piece is this? What is that? It looks like a
10p.
It's a 10 pence. 10 pence. There you go. If the autofocus wants to work. Yeah, 10 pence.
No.
That's all good. That's cool. What's up, Falcon? How's it going, bro? Hiya, gold. Finish your finals.
That's dope.
Congrats, dude. Nice, dude. We'll give you a big clap. Give me some claps for that. Good job, dude. Finish his finals. Nice. He's a free man. It's actually kind of early to be finishing finals. We're not even in May yet. That's quite crazy that you're already done with finals. Yeah. But okay, Nick, do you understand that? Okay. So whenever you have the probability of a couple things happening in a row, you need to multiply the probabilities together. Don't add them. Okay?
I didn't read in a row. That's why.
Well, yeah, it's not really worded that way. Ooh, new job. Remind us of your new job, Falcon. What's your new job? I remember it was something with like management of forests or something.
Forests.
Yeah. Okay, infinitely many solutions. Okay, this is cool. Do you know when something has infinitely many
Me out
solutions?
so hard.
Okay. Infinitely many solutions is when you solve an equation and you get something like 3 equals to 3. Or like, I don't know, like 4 is equal to 4. This means infinitely many solutions. Okay?
Bruh.
Yeah.
But how is equal to each other? I mean, that's...
Okay. I'm going to show you. Okay. Well, let's explain it with like a line, okay? Let's say we have 2 lines, okay? No, 1 second.
So I got it wrong. Okay.
It's okay. Let's say, for instance, we have like 6x. Let me make it easy. Sorry. Let's say we have 2x plus 2 is equal to negative 2x. Sorry. Let's say negative 2x plus 2 is equal to 2x minus 2. Falcon says field maintenance with trees, trails, and buildings in addition to bud scoring and the care of a 1-acre oak plantation. Wow, that's very cool. Rating buds by their appearance. When I hear buds, I think of like my bros, like my friends or something. Like, let me rate my buds. Okay, let's pretend that this is a line, though. Let's pretend this is like line 1, right? y1 is equal to 2x minus 2. Let's pretend this is another line, y2. Or let me make different colors for some shit. All right, let's say this is like y1. Okay. And then let's pretend that this is y2. Okay? And then let's try to graph these lines, okay? So 2x minus 2, right? That's going to look like something that's down 2 and then has like a slope of 2, all right? So it's going to look like something like this. Or here, I should really draw it like that, okay? Then negative 2x plus 2, right, is going to look something like this. Okay? Well, let me make sure I did that right. Yeah. Okay? Do you see how both of these lines intersect?
Yeah.
Here in one spot? That means that this equation has one solution. There's only one value for x, right? There's only one position where this side equals this side. And that's x is equal to 1. You see like 2 times 1 minus 2? That's 0. And you get negative 2 times 1 plus 2. That's also 0. Okay. Do I know ArcGIS? I've heard of ArcGIS. It's like it's GIS, right? That's like geographic survey stuff. It's like mapping out geographic stuff. I've worked with GIS a little bit. The buds and the weeds. Yeah, GIS is cool. It's for like mapping like territories and stuff, I think, right? Oh, it's the non-free QGIS. What does GIS stand for again? What does GIS stand for? It's like geographical something. Yeah. Okay, so but the point here, right? Do you see how this only has one solution? Yeah? Let's say we had a different thing. Let's say, for instance, I had y was equal to 2x minus... Let's say we had 2x minus 2 was equal to 2x... Well, let's make a different color. Let's say, one sec. Do a purple one. Let's say this is like 2x minus 4, right? Oh, Geographic Information System. That's what it stands for. Thanks. Yeah, okay. So 2x minus 4, right, would look like this. Okay? Where does the red line and the purple line intersect? It's a trick question.
They don't.
They don't. Yes. Why do they not? Because they are...
Parallel.
Parallel. Yes. Do you see how this same slope, right? But different intercepts, okay? This is an example of no solution, okay? If I wanted to solve this, watch what happens, right? Minus 2x, right? This goes away. And I'm just left with negative 2 is equal to negative 4. Do you see how this is like a nonsensical solution? This doesn't make sense. Like negative 2 does not equal negative 4, right?
Yeah.
Good. That means when you try to solve an equation using algebra and you get something that doesn't make sense, that means no solution. Yeah. Okay, cool. All right. Let's say, however, instead of like 2x minus 2, I had this. Let's say I had 12x minus 12, okay? Which would, I don't know, look something like, let me think what I actually want to do here, sorry. No, I don't want to do that, sorry. Let's say I had this, 2x minus 1, okay? This would simplify to 2x minus 2. Do you see how this would be a line that's the exact same as the one on the left?
Yeah.
Right? Okay. This, how many times does the blue line now touch the red line?
Infinitely.
Infinite. Yes, that means there are infinite number of solutions. So if I were to solve this, do you see how I would get 0 is equal to 0? This is infinite number of solutions.
Bro, really?
Yeah.
That's dope.
So it would be A?
It would be A, yes, because this is where like they basically just equal each other.
Bro.
Yeah.
Man, they could have worded it a whole different way, and I would have gotten it correctly.
Well, yeah, someone should have taught you it differently. It's okay. If you have practice tests like these, bro, you should like, go through them and then ask me on the stream to teach you it. I'll teach you it, dude. That's the whole point.
No, if I had, I would.
Yeah.
I have nothing.
Okay.
I went through the whole year of what I did,
What's the
I
name of this
just
test?
redid it all.
What's the name of this test you just took? What's it called?
MAP.
Oh, was it for Massachusetts?
No idea. Maybe. Yeah, the NWEA. That whatever that is.
I
That's what
said
took.
meth. Sorry, math. It's this, right? It's this.
Yeah, that. Yeah.
Okay.
Mm-hmm.
All right. Cool. So I think I can say, look, I can literally say map test practice, bro. There's literally one right here, dog. Like, what are you talking about, bro? Look, practice tests and videos.
They don't tell us anything about it.
Well, you can use Google. I know y'all
I
can use
didn't.
Google to like look up, I don't know, Cara Delevingne's nudes or something, bro. Like, use it to like
Who's
search up
that?
like practice questions for math, please.
Wait, let me go back in the VOD and listen to what you named. Who you
It's
named.
okay. It's okay. All right, look. You can literally select it. What grade were you in?
Bro.
12th, math,
Bro.
English, practice test. Look, all the practice tests. Look, go.
Bro.
Look, bro. There's literally a bunch of practice tests here, dog. Yeah.
I'm sad.
It's okay. Learn.
Well, thank you for showing me this while I will never need it again.
Well, you might have to take it again. Well, I guess you cheated on this one. So
I
whatever.
hope not. I don't know.
Yeah.
I mean, the one that I did for 11th grade, I just picked random things. So
All right.
I mean, I passed that one, I think. So.
Okay. All right.
They
Anyways.
say that you have to do this. It's mandatory to graduate, but they do not grade it.
It's kind of dumb. Here, let me do this last question with you to probably teach you something. Okay. It says the volume of cylinder can be found using this formula. They give you the formula, okay?
Mm-hmm.
So this is like a cylinder. Right? Okay. So this right here is going to be R. Right? This is H.
Mm-hmm.
Okay, a cylinder has a diameter of 2, so they're trying to fuck with you already. They said diameter, right? But I need radius.
Yeah.
Okay, so I know I want to convert that right off the bat, right? I want to say no. This is 2. This is 1 inch. Right here, let's use, I can't use it. I can't see this color, dude. This is 1 inch. Okay. And here's a new cylinder. We're gonna say R is equal to 2 inches. Okay. So this is like volume equals volume. So all right, they say a cylinder has a diameter of 1 inch and it is filled to a height of 4 inches. So we got to find the volume in the first cylinder, which is pi times the 1 r squared times the height, which is 4. Okay? That gets you 4 pi. That's the volume, the amount of water in the first one. It's then transferred to a second cylinder, which, again, is going to have a diameter of 2. So we're going to say pi times 2 squared times some new height. And that's what they want to know. They want to know what's the new height. Well, I know the volume of water in the first one has to equal the volume of the water in the second one. So 4 pi has to equal to 4 pi times h. What does that mean h is going to equal?
I don't know.
4 pi is equal to 4 pi times what? One. 4 pi times 1 is 4 pi. Do we see that, Nick? Do we see that, Nick? If I divide 4 pi by both sides.
Oh, yeah.
You see h is equals to 1?
Yeah.
Answer's 1. Yeah?
Huh?
Answer's 1 inch.
I think I pressed one. I don't know.
Okay.
I hope.
Okay.
Yeah, when it said the first one goes into the second one, I was like, no.
No, it just means the volume. It means the amount of water in the first one is the same as the amount of volume in the second one. That's all they're saying.
Oh.
It has to do with this, Nick, right? Like you have 2 cylinders, right? One is like this. And then you have one that's even bigger, right? So you have one that looks like, I don't know, like this. Okay?
Mm-hmm.
And they were saying, right? That if
Were
I
they looking for the height of the cylinder or the
No,
height of the water inside?
the height of the water in the second one, right? So this, right, is going to have some
Oh.
volume, and when I transfer it into here, right, it's going to have less of a
Yeah.
height, but still the same amount of volume.
Yeah.
Okay?
I thought I was looking for the height of the cylinder.
No, they want the height of the water level, which is like a cylinder. It's like part of the cylinder.
Mm,
Yeah. Okay.
Cool.
Cool?
Mm-hmm.
All right, cool.
Thank you.
You're welcome. All right, Taco, last one of the day.
But tomorrow or whatever, I'll send you the rest of them.
Oh,
I
yeah.
took a few pictures.
Oh, yeah. I mean, let's go through them like all next week. I mean, I'm not streaming tomorrow, but yeah, next week.
Yeah, okay.
Yeah, tomorrow's Thursday. Tomorrow's my day off.
Mm.
Like Dr. Gold has some day of rest. All right, Taco, I'm gonna. Wait, Taco keeps
All right,
asking
thank you
like
so
like
much.
you're welcome, dude. Sorry, let me read the chat. What's happening with Oak? Anyone know how to find the angular frequency of an AC circuit overall power source when there is multiple sources with different angular frequencies? Is that for analysis? Says simple series circuit with 2 power sources and resistor. First source is 10 cosine 500t. Second source is 10 cosine 100t. What is the frequency through the resistor? Oh, this has to do with impedance. Yeah, this has to do with impedance. Impedance, no? I mean, you can kind of look this up, right? You know, 2 power sources, different frequency. Google's your friend, you know. There's got to be some equation on it. Mm-hmm. Yeah, no, I mean, this gets you what the power is. You want to know what the frequency is? I mean, there isn't a frequency. That's the problem, right? Because you have 2 different sources. Yeah, Taco Cat. We're gonna do yours next. Here, mixed frequency. It's the least common multiple. I mean, that would make sense. This is the way to do it, though, right? And this goes back to phasors, right? Which has to do with this, right? So you end up calculating the impedance for different things, right? So, okay, you do it for the 60 source alone, you do it for the 90 source alone, and then you superimpose the voltage drops. Okay, it says, because the 2 voltages are at different frequencies, we cannot consolidate into a single voltage. I don't know, check this out. I think this is a pretty cool. Oak Spirit, read this. I do like this page. I've used this All About Circuits page before a lot. They're very cool for figuring stuff out. But in general, you want to get good at doing this. You want to get good at writing down the impedance, right? This is Z, the current, and the voltage in phasors. And then you use phasors to add and superimpose and whatever make it nice. Wait, Sensation, didn't you do electrical engineering? Or you just repair a lot of circuits? Do you know anything about like impedance and stuff like this? I forget.
No, I'm just a big lunk.
I'm just a big lunk.
I take the probe and go, does this work? Yes.
Yes, okay. You're an experimentalist, like me. An experimentalist, yes. Okay, I got you, dude.
Well, they're all
good.
modular. The stuff that I repair is all modular, so you just rip one piece out and put in another, and that's pretty much all there is to it.
Oh, okay. Nice. Just easy. All right, let's see. Taco Cat want to ask a question. What do I want to do with you, Taco Cat? Last time we did like, what's the maximum height of the ball? Yeah, that was a good one. Okay, so that's usually one that gets answered. Oh, here's the other one that gets answered. Here, this is a really good one. Okay, let's say, okay, here, Taco Cat, you ready to learn some physics? Experimentalist, didn't you see him flipping coins earlier?
That's dope.
I did see him flipping coins earlier. We know he's an experimentalist. Yes. Okay, cool. All right, let's say a man throws a ball horizontally at 20 meters per second off of a 100-meter tall building. And what someone can ask here, right, is how far from the building does building does the ball land? Okay? This is a really good question that gets asked. Okay. So, one sec. We got to go back and find where I put the Kinemax equations for you. A long, long time ago in a galaxy far, far away.
A man throws a ball from a 100-meter building. How far away from the building can you get before the cops catch you?
Bro, did you see the graffiti they did on that building in Los Angeles? Or my hometown, I guess, where I live, yeah. It's pretty cool. I'll show it to you in a second.
Graffiti?
It was decent. It wasn't bad. Yeah. Do I not have my equations here? Let me put them somewhere. Oh, there they are. Found them. We do a lot of things here in office hours. There we go. Okay. All right. So I always like to kind of draw a picture here, Taco. So I got building, right, which is 100 meters tall. And then we have Le Ground, which is this way, right? And then we're taking a ball. And we're throwing it. Throwing it this way, right? Here. At 20 meters per second. And we want to know, how far does it end up here, okay? All right, Taco? Maybe hop in the Discord so that I can talk to you quicker, because it's kind of hard to do this over Twitch. Yeah, it'll take a bit.
The lag is real.
The lag is real, dude. Twitch needs to fix their shit, dude. All right, Taco, here, cool. Yeah, let's do it. I gotta go in like 10 minutes. All right. So, using our equations, right, we would like to figure out this, right? This is like, what we say is like delta x, okay? I want to figure out how far away this ball lands, right? We could use, right, for instance, one of these equations to figure that out. Let's use this one, for instance, okay? So I'm going to say, cool, delta x is equal to VIT plus 1/2 AT squared, okay? This is what we're looking for. Do you remember what VI is? What's VI? Initial velocity. Yes, good, right? And more importantly, this is only in the x direction, okay? So this thing says it's being thrown horizontally. That means only in the x direction. So VI here will also just be 20 because it's only in the x direction. Okay, times t. I don't know the time, right? I don't know how much time it's in the air yet. Plus 1/2 AT squared. Do you know what the acceleration for this ball is in this direction? It's okay if you don't. Yeah, so okay, so we did this. What's this variable here? What's this a thing that we have to plug into our equation as well? What's that? What does a stand for? Right? You got v right? Like v was velocity. What does the a stand for? Distance. No. So A stands for acceleration. Okay. So this is gonna be the acceleration. But the acceleration in this direction, Taco, that's always 0. There's no acceleration in the x direction, unless there's a force in the x direction, but there isn't. Okay, so this is gonna go away. All right, so now we're just left with delta x is equal to 20t. So this is cool, right? I could figure out the distance that this thing travels if I only had the amount of time that this ball is in the air, okay? This is a cool thing with like two-dimensional, this is called two-dimensional because we have things moving up and down and left, right? So in two-dimensional kinematics, an important thing here is the amount of time it takes for it to go this direction, right? Like in the x direction, is the same amount of time it takes for it to just drop. And then combined, it's going to do this. So you see how it's moving this way and it's moving this way, but it's going to do both of those things at the same time. So if I can solve for the amount of time it takes for it to fall, that's the same amount of time it takes for it to go this way. So we're going to use this equation again, but we're going to use it in the y direction. So here, this was the x direction. This is going to be the y direction, okay? In the y direction, we're going to have delta y is equal to VIT plus 1/2 AT squared, okay? Now, delta y, right, that's how much the y changes. If the y starts at 100 and ends down at 0, what is the change in y? That's what delta means. It means change. What is the change in y if it starts at 100 and it goes to 0? So close. It's going to be negative 100, okay? It's negative 100 because it's going down 100, right? It's going from positive 100 to 0. Change is like, so delta is always equal to final minus initial. Yes, because we're going down. Cool. The initial velocity is going to be 0 because we're not putting any speed into it, throwing it down. We're just throwing it horizontally, okay? Acceleration is always negative 9.8 for things that are in the air going up and down. And we don't know t squared yet, okay? So this gives me negative 100 is equal to 1/2 times 9.8, so that's negative 4.9 times t squared. You can now divide by negative 4.9, divide by negative 4.9. And this is going to be, I don't know, this is approximately 20. And that's equal to t squared. Okay? Which then, right, we take the square root of both sides. And I get that t is equal to the square root of 20. Cool? Okay. Now that I know the amount of time it takes for this thing to fall down, Taco, that's the same amount of time it takes for it to travel this way. So I can take the square root of 20 and just plug it into here. Okay? So now that gives me, right? Delta x is equal to, oh, not into here, sorry. I can plug it into here. Is equal to 20 times the square root of 20. I miss doing this stuff. It was nice and fun. Yes, right? Back when things were okay. Back when things did not hurt. Back when we weren't doing these phasors. Oak Spirit. Yeah. Honestly, it's why I enjoy teaching it, just because it is like enjoyable for me. It's relaxing. But yeah, cool. All right. So this gets me at delta x is equal to 89.44. All right. And so that is the distance horizontally that the ball travels, is 89.44 meters. Cool? I think that was cool. Nice. Nice. I actually like phasors. Okay. I don't know. They are cool, I guess, but, you know, I don't know. I didn't like, yeah, when the node rules do, when, like, Thenovin stuff and whatnot, dude, I hate all that. Like, that stuff needs to chill. Needs to chill a lot. Okay. Cool. All right. I think that's all the questions. Yeah, right? We did it? That's awesome. Cool. All right, little quick announcements. So, no stream tomorrow, but on Friday, we are going to have our Golden Hour AMA podcast. I'm bringing that back. And we're going to have Eat of the Pie Eye, Zach, on our stream. So, he's a really awesome guy who he runs his own math help stream, and he's he's in grad school. He's a math grad student. And a lot of people ask me, like, what does a math grad student do? Now is the time to ask a math grad student, what do you do? Because it's an AMA. You can ask him anything. So in our Discord, you'll see here there's a channel called Submit AMA Questions, where we have a nice little bio about Zach and whatnot. And you can ask whatever question you want to ask of Zach. And so here's kind of the fun thing. Is that at the end of the AMA, Zach will pick what he thought was the best question, and that person wins $20. So if you want a chance at winning a $20 gift card, ask a cool question from Zach, put it in our channel, and come by on Friday. That'll be at 6 p.m. Pacific, 8 p.m. Central, 9 p.m. Eastern, and we're gonna go through all the questions you have from him. We're gonna have a really fun time. It's awesome. 7 p.m. Mountain.
Nice.
Yes, Jeff. Yes. I hope to have all the math chads there. That'll be fun. Yeah, all the math guys. You want to come by and feel free too. Maybe I'll make a Google form or something, to send out to Penn Center, for his channel, for his thread and whatnot, so that if you guys have questions you want to ask Zach on the stream, you can also submit it and we'll go through them. That's a good idea. Let me remind myself to do that. Let me say, yeah. Here I'm gonna say. Remind yourself to send out Google form to other servers. Cool. Just so I remember. Okay. Cool. So yeah. So come by for that. That's gonna be a lot of fun. And then yeah. And then our next homework help stream will be on Monday. That's gonna be at 3 p.m. Pacific, 5 p.m. Central, 6 p.m. Eastern. And then this is the last weekend for you to submit entries for the talent show. So if you have a cool talent and you want to maybe win a PS5, submit me a video of something cool that you're doing. The rules again they're all on our Discord. If you're new from Twitch and you have no clue what any of this is, like go join the Discord. It's right there. And I have everything there is laid out. We do a lot more than just giving out help for math and science questions. We give out prizes for all sorts of fun stuff. We'll probably have another chess tournament on Sunday. That was a lot of fun. But I'll announce all that in the next day or two. Anyways. Okay, cool. I gotta go teach more. Let's see. Let's go raid someone. Who's streaming right now? Oh, let me put the closing credits. All right, thank you, everyone. Coming to office hours. Super fun. Danny? Should we raid Danny? Yeah, Danny's always fun. What's Danny doing? Danny's playing video games, though. I always like to raid someone who's doing science. Moohoodle's doing science. Yeah, go say hi to Moohoodles. I haven't seen Moohoodles in a bit. We should raid and ask him about the trolley problem to mess with him. Okay, no, we can go raid Danny. That's okay. We can go raid Danny. All right, everyone, go say hi to Danny and go ask him about the trolley problem. Okay. Yeah, I guess that's funny. All right, yeah, we'll go raid Danny. Okay. All right, here we go. All right, awesome. Yes, I will see you guys on the AMA on Friday. Come on by, have some fun, have a great rest of your Wednesday. Peace out.